Hello. So let's do another example. And the point of this example is to do something a little bit harder. We're going to have to do a couple different rules in one, but it's going to go almost exactly the same as the previous examples. So just like the previous examples, we want the derivative of a composite function. And then hopefully we can kind of see that the outside is, something raised to the fourth power. And then that something, the inside, is going to be this x plus 5 divided by 2x squared plus 3x plus 2. And so let's write that down. Let's say the outside is, something to the fourth, so u to the fourth. And then our inside, our u, is going to be x plus 5 divided by 2x squared plus 3x plus 2. Great. And then now we're going to proceed like we have been proceeding. So we're going to take the derivative of our outside and then the derivative of our inside. And so the derivative of our outside, this u to the fourth, is just 4u cubed. So this is going to be 4u cubed. And then now we take the derivative of the inside. But this is a fraction. This is a quotient. And so we're going to have to use the quotient rule. And so let's remind ourselves what the quotient rule is. So the quotient rule says if you have like a function divided by another function, so if you have a high function h and then the low function L, then the derivative is low d high minus high d low over low squared. That's the mnemonic I use. So it's going to be low times the derivative of the high minus high times the derivative of the low divided by low squared. And so now let's just put that all together. So we want the derivative of this. So we do low d high. So we're going to do 2x squared plus 3x plus 2. That's the low. So 2x squared plus 3x plus 2 multiplied by the derivative of the high. So the derivative of x plus 5 is 1. And then we're going to subtract high d low. So we're going to subtract high d low. So our high is this x plus 5. So minus x plus 5. And then now we take the derivative of the low. So we're going to do the derivative term by term. So the derivative of 2x squared is 4x. So we're going to multiply by 4x plus. And then the derivative of this 3x is just 3. So we do 3. And then we can close the parentheses because the derivative of 2 is 0. So this is our top. And then now our bottom is going to be, so that was this right here is the low d high minus high d low. And then now we're going to have the low squared. So we're going to do 2x squared plus 3x plus 2 squared. Great. So that's just the rule for a quotient rule, the derivative of a quotient. And so now let's combine it. So now we just do exactly what we have been doing. So we're going to do the derivative of the outside evaluated at the inside. So we're going to do this 4u cubed evaluated at our inside. So we're going to do 4 something, big parentheses, cubed. And in that something is going to be the x plus 5 divided by 2x squared plus 3x plus 2. Here, let's clean this up a bit. There we go. That looks a little better. And then now I also want to point out, so we can simplify our u prime. We can if we wanted to. So this x plus 5 times this 4x plus 3, if we multiplied this together, we would get a quadratic. And then we could subtract and simplify, and we would get like a simplified top divided by this thing squared on the bottom. You can do that, and maybe your teacher might even ask you to do that. I personally don't mind if you leave it this way. I think it's totally fine to leave it like that, but it depends on your teacher's preferences. So I'm just going to leave it like this. So now let's multiply by the derivative of our inside. So we're going to multiply by this, and so we multiply by the derivative of the inside, so we're going to multiply by this whole big thing. So let's do big parentheses, and then 2x squared plus 3x plus 2 times 1 minus x plus 5 times 4x plus 3, all divided by 2x squared plus 3x plus 2 squared. And that's it. So again, this is the derivative of the outside evaluated at the inside multiplied by the derivative of the inside.